Elon is thinking about future generations with every move he makes, like his plans to build a human base on Mars and to make space not just a tourist destination, but also to create a world that will hang out in space, allowing humans to freely navigate between space and Earth at any time, similar to taking a taxi on our earthly road. Elon Musk and SpaceX have been working on the Starship and the Raptor engine for quite some time, but the speed of the Starship is too sluggish to produce a quick and short-duration shuttle between Earth and Mars. So what could be an alternative to the Starship or have a speed 200 times faster than the speed of the Starship? Of course, it's the speed of light. Certain questions may arise in our minds, like how this engine would be built, and what kind of fuel will it require if it genuinely works without propellant? And what will be the human travel mechanism for reliability and safety when traveling in a spacecraft moving at the speed of light? Let's find out the answers to all of these important questions in this video. This is Tech Space. If you're new here, we specially invite you to join many of our lovely fans. Kindly subscribe and click on the notification bell. It motivates us to produce more fantastic content like this, and you'll have a lifetime access to all of our high-end tech videos. Let us first clarify the fallacy regarding the speed of light. Such speed may be proved effectively by using the flash of a touchlight. Remember how quickly the flash of a touchlight hits the surface of an object? That's the speed we're talking about here. Light travels at exactly 299,792,458 meters in 1 second. In fact, to put that into astronomical perspective, if you could move at the speed of light, you'd be able to go around the globe nearly 7.5 times in a second. Meanwhile, traveling at an average speed of around 800 kilometers per hour or 500 miles per hour would take more than 50 hours to complete a single cycle around the Earth. So you can see how fast the speed we're talking about is. NASA and SpaceX have collaborated to develop a rocket engine with enough force to propel spacecraft at the speed of light. And this engine practically breaks Newton's third law of motion, an engine concept that can accelerate to 99% of the speed of light while using no propellant. That may seem like something from a science fiction movie, but it isn't. This is precisely what one of NASA's engineers is working on. How will these engines be built? If it is to function without propellant, what will be its fuel? Most importantly, will humans be able to ride in this type of vehicle with such a thruster engine? We'll find out in a brief moment. We have a problem with our human desire to travel everywhere and examine everything when it comes to space. This is a major problem. After all, it is space. It's way too big. NASA engineer David Burns' study has been just what we need to take space exploration to the next level. He's created an engine concept that he claims can accelerate up to 99% of the speed of light with no propellant. This is a discovery that was introduced in the EM drive, and David considered experimenting with it to see how it might operate in a rocket engine. NASA was the visionary company that came up with the idea of developing an engine capable of traveling at high speed in space with a speed that competed with the speed of light. EM Drive, first proposed in 2001 by Roger Scheuer, a British chartered electrical engineer with 48 years of experience in the space and defense sectors, is a radio frequency resonant cavity thruster concept with potential applications as a spacecraft thruster. It is claimed that it generates thrust by internally reflecting microwaves, which is contrary to the law of conservation of momentum and other fundamental concepts. The invention has been nicknamed the Impossible Drive by the media. There is no official design for this device, and neither of the people who claim to have created it has committed to detailing how it works. As a thruster or what parts make it up, making it hard to establish whether a certain object is an example of such a device. While the helical engine is interesting, despite promises, it is unlikely to defy the laws of physics anytime soon. Although his concept has been treated with skepticism in certain areas, Burns feels it is worthwhile to pursue. What exactly is a helical engine and how does it operate? So let's get this one out of the way. Every action has a reaction. It is the guiding concept of all space rockets, which shoot propellant in one direction to go in the other. However, NASA engineer Burns believes he can send us to the stars with no propellant at all. That alone violates Newton's third law of motion, as we were taught in school. Remember, action and reaction are equal and opposite? That's it. Other physical scientists have expressed doubt, but Burns feels his concept is worthwhile to pursue. I'm fine with putting it out there, he adds. If it doesn't work, I'll be the first to admit it was worth a try. To understand the idea of Burns' engine, Imagine a box on a frictionless surface. There is a rod within the box down which a ring can move. If a spring within the box pushes the ring, it will glide down the rod in one direction while the box will recoil in the other. When the ring reaches the box's end, it will bounce backwards, and the box's recoil direction will change as well. This is action-reaction, known as Newton's third law of motion, and it normally limits the box to wiggle back and forth. But Burns wonders, what if the ring's mass is much more when it moves in one way than the other? The box would then get a stronger kick at one end than the other. The box would accelerate ahead because action would outnumber response. Physics does not forbid this change in mass. According to Einstein's theory of special relativity, things gain mass as they are accelerated towards the speed of light, an effect that particle accelerators must account for. In reality, a simplified version of Burns' plan would be to replace the ring with a circular particle accelerator, in which ions are rapidly accelerated to relativistic speed during one stroke and decelerated during the other. However, Burns believes that it would be more practical to forego the box and rod and instead use the particle accelerator for both lateral and circular movement, in which case the accelerator would need to be configured like a helix. We think this should not be entirely feasible, according to the concept of momentum conservation, which states that the momentum of a system remains constant in the absence of any external influences. According to Einstein's theory of special relativity, things gain mass as they are accelerated at high speed, close to the measure of the speed of light, an effect that particle accelerators must account for. Burns' drive, on the other hand, does not consist of a single closed loop. Because this is helical, like a stretched out spring, it's termed a helical engine. The engine accelerates ions in a loop to relativistic speeds and then modifies their velocity to modify their mass. Scientists claim that the helical chamber would have to be rather large. To be precise, it is 200 meters, about 656 feet long, and 12 meters, roughly 40 feet in diameter. 1 Newton of thrust would also need 165 MW of energy. That's the amount of force required to accelerate a kilogram of mass per second squared, which is similar to the output of a power plant. Proposals for propulsion-free vehicles, such as helical, aren't entirely new. The idea has been fully proven, and both are widely thought to be impossible due to the violation of a basic physical law, the conservation of momentum. Burns has worked on his idea in secret, without the support of NASA, and he admits that it is tremendously inefficient. He claims, however, that there is a possibility to collect most of the energy that the accelerator loses through heat and radiation. He also provides techniques to conserve momentum, such as in the spin of the propelled ions. At this point, we have to admit that our skepticism is well-founded, but don't be fooled. We shouldn't be astonished if a faster-than-light capable engine appears in the future, given the rate at which aeronautical technology is evolving. When that occurs, all of our science fiction imaginations will be on a direct path to becoming science truth. Do you believe David Burns' propelling invention will one day become a reality and be utilized as a rocket engine to lift off rockets into space? Please do well to share your thoughts in the comment section below. Until next time, please like, share, subscribe, and while you're still around, why don't you click on one of those flashing videos on the screen for more content?